Okay, to solve an inequality algebraically, we first have to factor it. So we're going to assume that this is the factored form. Perhaps we've been given a more complicated one and we've got it down to this now. So once you're down into factored form, you can say what the zeros are. So our zeros then are -3/2, +1, and 2/3. Then I'd like to set up the interval table. So I'm going to draw a straight line, and in the leftmost column I'm going to put the factors. Now this minus sign, this minus sign right here, I'm going to include it with this factor while I'm doing my testing. So I'm just writing down each factor in the leftmost column. Now, each of these factors are multiplied together to give our final f at x, whatever it was originally. At the top, I'm going to put all the numbers for my intervals. So here we'll start with -infinity, and then the most negative one out of the three I have there is -3/2, and then the next one up would be 2/3, and then 1, and then positive infinity on the right. So now I'm going to check numbers in each interval. So I'm going to check numbers here, and then here, and then here, and then here. So checking first between -infinity and -3/2, I could choose -2, for instance. I'm going to substitute -2 into the 2x plus 3. So 2 times -2 is -4, plus 3 is -1. So this, oops, sorry about that. This is negative here. Did I do that right? Now I've lost track of what I'm doing. Sorry. -2 times 2 is -4, plus 3 is -1. With a negative out front makes positive. I'm still using -2, and I'm going to use it in this factor here. So -2 subtract 1 is -3, gives me negative. Now I'm going to use -2 again in here. So 3 times -2 is -6, minus 2 is -8, so that's still negative. So together, looking down the column, I have a positive, a minus, and a minus. That means the function will be positive in this interval. I'll move on to the next interval. Between -3/2 and 2/3, there's actually, I'm going to try 0 in there. So here I tried -2. Here I'm going to try 0 in all of my factors. So looking at 2 times 0 plus 3, so that's positive, but the negative out front makes it negative. 0 minus 1 is negative, and 3 times 0 minus 2 is negative. So 3 negatives will actually make this interval negative. Now going between 2/3 and 1, well, let's say we'll try 3/4, or 0.75. 2 times 0.75 is 1.5 plus 3 is 4.5. This is going to be negative. 3/4 minus 1 is also going to be negative. 9. So 3 times 3/4 is 9/4. So that's more than 2 minus 2. So that'll actually be positive. So then this interval will be positive because two negatives and a positive make a positive. My final interval, let's try the number 10, because it really doesn't matter what you do as long as it's between 1 and infinity. So we're going to try 10. 2 times 10 is 20, plus 3 is 23 with a minus out front. So this is minus still. Then 10 minus 1, looking at the second factor, is 9, so positive. 3 times 10 is 30, minus 2 is 28, so also positive. So this interval, I actually am negative. Once we've done this whole table, now we can just answer our question. Our question was right here, when is that function less than or equal to 0? So it'll be less than or equal to 0 here and here. So therefore, f at x is less than or equal to 0 in the interval -3/2 less than or equal to x less than or equal to 2/3. So I'm just copying down these numbers. And then also in the interval between 1 and infinity. So I'm going to say x is greater than or equal to 1. And then that would be the end of the problem. I've included the graph so that I can verify that I've got the correct answer. So our function then is less than or equal to 0 anywhere it's below the x-axis. So that would be between -3/2 and 2/3. That would be this first interval. And then also after 1, so you can see it's below the x-axis in those points. Good luck.